All right, so this is the calculator part for the Polynomials chapter test review. I wanted to redo these 3 problems using DESMOS instead of the graphing calculator, but you could use either on your test. So, first problem says you have 100 yards of fencing to enclose a rectangular region. So let's just go ahead and say our dimensions of our rectangle are x times y. So we know right now that 2x plus 2y is equal to 100. Find the dimensions of the rectangle that maximize the enclosed area. What is the maximum area? Remember to consider domain of x if we're trying to fit this into a window. So now, a lot of you know that if we're just talking about a straight rectangle, we don't have a line down the middle, then a square will always give us the largest area. So if I have 100 yards of fencing, I can divide that by 4, and it should just be 25 by 25 is my largest area. But if you want more of a formula for that, or if we do put a line of fencing down the middle, what you need to do is adjust your perimeter equation, solve it for x or y. I tend to solve for y. And then come up with an area equation. So the area of this rectangle is x times y. But we want an area equation that just has one variable. So I want a to be a function of x. And I'm going to replace this y with this expression, 50 minus x. And if I'm looking for the max area, I can find the vertex of this quadratic. That will give me the x value and the maximum area. So the vertex is, like I said, it should be 25. But let's just go ahead and do this. Because again, if we have a line of fencing down the middle, like we've had in some problems where this is maybe 2x plus 3y or something equals 100, then you can't get a perfect square. So you would type in a of x equals x times 50 minus x. What about domain here, if you're having trouble seeing this? Well, remember, for the area, you would need each of these dimensions to stay greater than 0 so that there actually is an area and we don't just get negative area or 0 area. So x has to be greater than 0. X has to be less than 50. So 0 to 50 is our domain. Now, you can either zoom out from here, or if you want to zoom fit, you can add a table and say go 0 to 50. If I do this, I usually put a number in between because remember, it won't show you the vertex. Oops. I want to type in a of 0 right here. It won't show you the vertex if you just use the zeros. It'll just show you the zeros. So the vertex is at 25. For a quadratic, it's in between the zeros. But yeah, the max is 25, 625. And so the 25 is the x, the 625 is the area. The question was find the dimensions, find x and y that give the maximum enclosed area. What is the maximum area? So the max area equals 625. We're talking about feet, I believe. No, yards. Okay, so square yards. And the dimensions are x equals 25 yards. And what about y? Y is 50 minus x, so y is 25 yards as well. Again, if you just have a rectangle and you can remember that, hey, in a rectangle, the largest area will be if you can make the rectangle a square, then you just divide your fencing by 4 to see what the 4 sides would be. That would give you the same answer. Okay, here's one where we're given the function and a domain. So the function f of x equals this with this domain. Models the U.S. movie attendance in billions of tickets sold X years after 2000. During which year was the movie attendance at a maximum? What was the maximum attendance? This sounds familiar. We either did this problem or we did the problem in the same context. I don't remember at this point. So I'm going to clear out this old stuff. type in f of x equals negative 0.03 x squared plus 0.14x plus 1.43. I'm going to do a quick check for typos. I think I'm okay. And when they give you a domain, you add a table with the endpoints of the domain. And then f of 0, and this one's f of 5. If this zoom doesn't show you the vertex, you can either zoom out, or you could include a third point, put something in between them, like 2 and f of 2. Or you could do 2.5, whatever, but the vertex is here. The question was, during which year, make sure I read this right, during which year was movie attendance at a maximum? What was the maximum attendance? So the maximum ordered pair is 2.333, 1.593. And remember, this is x and this is f of x. X represents tickets sold. Oh, I'm sorry. F of x represents tickets sold. And x represents years after 2000. So during 2002, because it's 2002 point, like in the first third of that year, the maximum attendance was 1.593 billions of tickets sold. Billion tickets sold. All right, what else do we have to do with our calculator? So find all zeros in the complex number system. Remember, complex number system means real and imaginary. Give me all the zeros for this function. So notice I'm not giving you any zeros to get you started if this is the calculator portion. So we're going to x out of this. So we need to type in this f of x. And we should, if this is x to the fourth, we should be able to get 2 zeros out of this. So f of x equals x to the fourth minus 3x to the third plus 6x squared plus 2x minus 60. All right, so let's click on these zeros. So from my graphing calculator, I got negative 2 and 3. So write those down. X equals negative 2 and 3. And those are two answers. The other two must be imaginary. So we can use this in any order with synthetic division to get this degree 4 down to a quadratic that we can solve. So I'm going to start with negative 2. 1x to the fourth minus 3x cubed, 6, 2, negative 60. Drop down the first number, multiply, add, multiply, add, multiply, add, multiply, add. This represents 1x cubed minus 5x squared plus 16x minus 30. So now, and this is the remainder. So now take the cubic result that you have and use the other 0 to get this down to a quadratic. Drop down the first number, multiply, add, multiply, add, multiply, add. This represents a quadratic. So now we can say all we have to solve is when is x squared minus 2x plus 10 equal to 0. This does not factor because the factors of 10 are 5 and 2, and there's no way that's going to add or subtract to negative 2 in the middle. So I've got to do quadratic formula for this one. So it's 2 plus or minus the square root of 2 squared is 4 minus 4 times a times c all over 2 times a. That's 2 plus or minus the square root of 4 minus 40 is negative 36. 2. That's 2 plus or minus 6i over 2. And because I can divide all three of these numbers by 2, I need to say 1 plus or minus 3i. So the zeros are negative 2 and 3, and 1 plus or minus 3i.